Good everyone. I welcome you again to the Good everyone. I welcome you to another episode of Chemistry of Selected Metals and Non-Metal. In this particular video, we'll be working on chemistry of nitrogen. First of all, let's talk about the position of nitrogen in the periodic table. We already know that nitrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen has the atomic number of 7 and the mass number of what? Of 14. So if you are to go by this, the electronic configuration of nitrogen, the proton number is 7, the electron number is 7, while the neutron number is 14 minus 7, which is going to give us what? 7. So let's write the electronic configuration of nitrogen is 1s2, 2s2, 2p what? 3, because 2 plus 2 plus 3 will give us what? 7. In the periodic table, nitrogen belongs to group 5 in the first 20 element periodic table or group 15 for a standard periodic table, and nitrogen belongs to period 2 in the periodic table. I repeat, nitrogen belongs to period 2 and group 5 or 15 in the periodic what? Table. So if you look at this, the first share is 1, 2, while for the second share it has 5. 1, 2, 3, 4, 5. So that is to say, nitrogen has 5 valence electron. Nitrogen has 5 valence electron. And how many electrons is remaining for nitrogen to be stable? Nitrogen has 3 electrons remaining for the octet to be stable, because for this structure to be stable, you need a maximum of 8 electrons. So because of this, there is a high nitrogen will not really want to give out 8 electrons. So there is a high tendency that nitrogen is going to look for other elements that has that are willing to share electron with himself, so that both of them can be stable. For example, hydrogen. Hydrogen can decide to come here, come here, come here to form a covalent bond between nitrogen and what? And hydrogen. So please, because of that, we believe that nitrogen has the oxidation number of +5 to what? To -3. Please, some person will tell you that it is +5 and -3. It's actually the same thing, kind of the same thing. But please take note, the oxidation number of nitrogen is +5 because you have 3 electrons in the atmosphere and what? -3, because we have 3 electrons remaining for the share to be what? To be stable. So that is for a general overview of nitrogen. Plus, please take note, there are a lot of questions that some persons do get confused at. Is nitrogen monatomic? Is it diatomic or a triatomic element? Please take note, nitrogen is a diatomic molecule. So it is wrong for you to write nitrogen as N. So in this case, we are going to write N2. So nitrogen is actually what? A diatomic molecule. There are some molecules that are triatomic, there are some that are monatomic, there are some that are diatomic. So nitrogen falls into the category of what? Diatomic what? Molecule. Let's quickly talk about the occurrence of nitrogen. Nitrogen actually occurs in free state, in combined state, and as an organic matter. So the free state of, or the free occurrence of nitrogen is actually in air. We believe that nitrogen occur, or nitrogen is one of the constituents of air. Air is a mixture of gases that is made up of carbon dioxide, made up of nitrogen, made up of impurities, water vapor, which is that one again? Oxygen. Those are part of the air, of this air we breathe. But nitrogen is a major substituent of the air. So why is it that if the mentioned air, oxygen do come to our mind? Please take note, among all the constituents of air, oxygen is the most active, but nitrogen has a higher percentage. The proportion of nitrogen in the air is 78%, while that of oxygen is 21%. So, but at the end of the day, whenever we measure air, our mind always go to what? To oxygen. So now, why is it that we don't consider nitrogen as the major one? Because nitrogen actually acts as a what? A diluent or a diluent to dilute the power of oxygen in what? In air. If you notice during the harmattan season, there are a lot of, the air is much. The presence of oxygen during harmattan, not even air, the presence of oxygen during harmattan is very, very high. That's why you can just dry a cloth now within an hour. You can just put your, within an hour is dry. A lot of things will happen during harmattan, and someone can just be walking by, drop a stick of cigarettes, I mean a used stick of cigarettes, After smoking and that, the person just drop it there. In the next 5 minutes, before you know, bush burning. And it's during Harmattan that's where you hear bush burning, because the percentage of oxygen in the atmosphere is high, and the nitrogen there is not enough to bring down the power of that oxygen. So then you are going to hear a lot of combustion, respiration, and what? Oxidation. So nitrogen actually dilute the power of combustion, dilute the power of respiration, dilute the power of what? Of oxidation in air. Please take note, it is 78% in the atmosphere. Then it also acts as a combined form. Nitrogen can also be seen in a combined form as a nitrate or what? Ammonium ion, maybe as a salt or anything. Then we have organic matter. It can be form of protein, urea, or vitamin B what? Compound. So these are the occurrence of nitrogen: free state, combined state, and as an organic what? Matter. Let's quickly rush to the physical properties of nitrogen. Nitrogen is colorless, odorless, and a tasteless what? Gas. Then it is slightly less dense than air. It is slightly soluble in water. The melting point of nitrogen is minus 210 degrees Celsius, and the boiling point is minus 193 degrees what? Celsius. What about the chemical properties of nitrogen? For the chemical properties, we already believe that it has 5 valence electrons. And for it to be stable, it needs how many electron again? It needs 3 electrons to be stable. And because of that, it undergo what we call covalent what? Bonding. And its atomicity, it is diatomic. I've said that already. That is nitrogen bonded to what? To nitrogen. So as long as nitrogen is bonded to nitrogen, nitrogen is very, very stable. It is very, very stable. So nitrogen doesn't even want to, on a norm, nitrogen don't want to react with anybody. It's not like a noble gas that don't want to do any work. It is very, very stable because of the triple bond between nitrogen to nitrogen, the atomic triple bond. So because of that, nitrogen is very, very what? Stable, and it doesn't want to react. So for nitrogen to react, you have to subject it to a high temperature and what? A high pressure. A high temperature and pressure can now make nitrogen to do what? To react. And nitrogen reacts with selected elements such as hydrogen, oxygen, and what? And selected metals such as magnesium. So nitrogen can actually react with hydrogen. If you react with hydrogen, you know the product that will be formed already, which is ammonia. It can react with oxygen. It can as well react with what? With selected metals such as magnesium. So please take note of that. So how do we prepare nitrogen generally? Nitrogen can be prepared using fractional distillation of liquid air. Fractional distillation of liquid air. So when air is compressed, you know what I mean by air, mixture of gases, when air is compressed to liquid, then you use fractional distillation by separating the different fraction of air. You can get nitrogen from there. Or in the atmosphere, like what I said earlier, we have 78% of nitrogen, we have oxygen 21%, we have which is that one again? CO2, we have 0.03%, we have noble gases, we have 1%, we have water vapor, which is what? It varies. Impurities as well varies. So what you do is that in the atmosphere, if you can remove all these things from the atmosphere, what's remaining here is what? Is nitrogen. So you can actually get nitrogen from the atmosphere by removing the other substances from it. What about ammonium salts? Such as NH4, NO2. So this ammonium salt, and this ammonium salt, you can use the reaction of this ammonium salt can give us what? Nitrogen. What about ammonium heptazodichromate, which is NH4 to here Cr2O7. So this guy here is going to give us what? Nitrogen. Please, it's not just nitrogen that is going to give to us, it's going to give us other products. But our major focus is the preparation of what? Of nitrogen. So fractional distillation will give us nitrogen. Atmosphere can give us nitrogen. Ammonium salt, which is diazonitrate 3, is going to give us what? Nitrogen. We have ammonia as well. From the reaction of ammonia, we already know that here is NH3, and this NH3 forward and backward reaction can give us nitrogen plus what? 3 molecules of what? Of hydrogen. So that's a balanced chemical reaction. Then we have dinitrogen 1 oxide. dinitrogen 1 oxide. If dinitrogen 1 oxide also reacts with copper, it's going to give us nitrogen and then copper oxide. So please, this is these are some of the ways in which nitrogen can be prepared. So what about the compound of nitrogen? We have compound of nitrogen such as the first one here is amine, the second one here is ammonia, the third one here is ammonium ion. So please take note. If here is NH2, it's called amine. If I change to 3, ammonia. If I change to 4 plus, is what? Ammonium what? Ion. And NH4OH is hydroxylamine. We have NH2NH2. It's hydrazine is also the same thing as N2H4. So this can be called hydrazine. We have oxide of nitrogen, so it has nitrogen, dinitrogen 1 oxide. We have nitrous oxide. We have nitrous oxide is actually dinitrogen 1 oxide. We have nitrogen 2 oxide. We have nitrogen 4 oxide and the rest. Then we have nitrate, which is NO3 minus, which can be sodium triisonitrate 5, can be magnesium triisonitrate. Any of the nitrates, you are going to see them there. Those are compound of what? Of nitrogen. Let's quickly rush through the uses of nitrogen. It's actually used as a preservative to oil and fat. What I mean by preservative to oil and fat, there's something we call rancidity in oil and fat, which is degradation of oil and fat to give us carboxylic acid, to give us arcanone and aldehyde, if I'm not mistaken. So for rancidity of fat and oil, what I mean by rancidity is more of degradation, breaking down fat and oil to give us other organic compounds such as carboxylic acid, arcanone, and aldehyde. What nitrogen is going to do to the reaction is that it's going to preserve fat and oil from rancidity. So it's going to stop fat and oil from being broken down into other organic compounds. So that's what nitrogen will do. Nitrogen is also a very good cooling agent, and nitrogen also helps in the production of ammonia, in the production of cyanide, in the production of ceamide, then carbamide. So nitrogen can actually be used in the production of all these compounds and more and more. So that is a general overview of what nitrogen, of the chemistry of what? Of nitrogen. Please take note. Nitrogen is the atomic molecule, and nitrogen supports not is very, very stable, so it doesn't even want to react. So nitrogen can only react at a high temperature and pressure. When it's subject to a high temperature and pressure, it can react with selected elements such as hydrogen, oxygen, and selected what? Metals. I want to ask you a question. Please, if you know the answer, drop that in the comment section. We believe that air is a mixture of gases, and like what I said earlier, the percentage composition of nitrogen in air is 78, and the percentage composition of oxygen is 21. So why is it that if we mention the word air, oxygen always come to our mind, not nitrogen? Please drop the answer in the comment section. Feel free to share this video to your friends, your loved ones, those who are offering CHM 111. See you in the next episode. But for now, goodbye.